Okay, good morning. And we're at a stage now in chemistry where we know quite a lot, but we need to put it all together. And this big question here is the title for today. Why do atoms and chemicals even react in the first place? So what we have now is some basic principles about the periodic table, about atoms, what atoms are made of, how the model developed. But now what we need to do is we need to understand, why would atoms do this? Why would they join up together? Why do some atoms join to three or four others and some only join to one other? This molecule glucose that's drawn in the background here and pictured here, why is glucose 6 carbons joined to 12 hydrogens joined to 6 oxygens? And we looked at formula before. So here's our chemical formula. So hopefully the next little bit of science and this lesson will help to tie it all together. And if you've got a firm understanding in chemistry of these basic principles of the periodic table and atoms, then the rest of chemistry actually becomes fairly straightforward, and you can always refer back to this. But it's like a foreign language in a way. There's certain rules here and you need to be fluent with them. So, a few questions to start with, and then once you've paused, had a go at those, I'll run through the answers. So pause now, and now you've played. A compound is made out of 2 or more atoms bonded together, and an element is made out of only one type of atom. And the atomic number, this question, tells us the number of protons. And carbon here, in this little diagram, carbon has 6 protons because the atomic number is 6. To get the neutrons, I say 12 take away 6. That's 6 as well, 6 neutrons. And the number of electrons, because atoms are neutral, electrons are equal to protons, so that's 6. So carbon has 666. Okay, once you've done those, move on. And you'll need a little bit of time on this slide. So if you listen to the explanation first, and like I say, if you can learn these basic rules, all of chemistry becomes much easier to learn in the future because you'll have the basics right. It's like knowing your alphabet before you learn to read. One's impossible without the other. So rule number 1. When we're looking at the periodic table and elements, the atomic number, I'm going to change to a highlighter for a second. Rule number 1, the atomic number tells us how many protons there are. And the mass tells us how many protons and neutrons there are. In an atom, every single atom, protons and electrons are equal. So if you've got 12 positive charges, you have 12 negative charges. 12 protons and 12 electrons. Protons are positive, electrons are negative. And that's what we've covered now in lessons 2, 3, 4 and 5 of chemistry so far. Electrons are in shells in lesson 6 and lesson 5 when we started to draw them. And you fill them up from the inside out. There's a maximum number in each shell. And there's the maximum numbers, the 2, 8, 8, 18. Then we looked at the number of electrons on your outside determines your group in the periodic table. So if you have 1 electron on your outside, you are in group 1. And if you have 2 electrons on outside, you're in group 2. And then the most important rule. Atoms want a full outer shell of electrons. And we did that last lesson with group 1. Group 1 lose 1 electron. They lose 1 because they want a full outer shell of electrons. And that's what the whole of chemistry is based on. If atoms didn't need to do anything, they would never have joined together. They would never have formed molecules like proteins or carbohydrate. We wouldn't exist. The only things would be the elements themselves floating around. So I would have these on a page, the rules. This will probably take you about 8, 9, 10 minutes. getting the rules on a page really clear, really well laid out, really neat. Maybe they're in boxes, maybe you put examples next to them, but get these rules so far absolutely laid out in a way that attention is drawn to that page, and this is something you go back to again and again until you are 100% fluent. And if you are finding that you've got any difficulty with any of these rules, all the way down to rule number 9, if you've forgotten them, have a look back on the last few pages of work since the start of January, find that bit. Okay, so if you're in the live lesson, you will have done this Kahoot, and the first 20 elements on the periodic table, you are expected to know their symbols and names. So that's a basic, so that when you see this, you straight away know that that's four hydrogens joined to a carbon. When you see this, you know that that is magnesium and fluorine, magnesium fluoride. The first 20 are the ones that for GCSE you need to know. Okay, so back to the question for today. Why do atoms even react in the first place? And it's because of rule number 9. Rule number 9, they want to get a full shell. So here I am, and I've got my sodium from the periodic table here, and I've drawn out my sodium. It's got its 11 protons in the center there, you can see them. It's got its 12 neutrons in the center in the nucleus, and it's got 2 electrons in the first shell, then 8, and then 1. So it had 11 electrons, and there's the 1. How does it get a full shell when it reacts? It needs to lose 1 electron. Easy as that. So please look at this, decide for yourself, how does this atom, magnesium, how does it get a full shell? So thinking, right, you've thought of an answer. If your answer was it needs to lose 2 electrons, if that's what you thought, then you are on the right track. You are correct. If you thought something different, have a look at it. It's got 2 in the first shell here, that's full. It's got 8 in the next shell, and then it had 2, and they're the 2 it loses. And then it would be left behind with a full shell on the outside, which is what rule number 9 says. They all want a full outer shell. Okay, here's a different one. So this one now is chlorine. How is this going to get a full shell? So have a think. And your thinking time is now up. You've counted them round. If you think the answer is it needs to gain 1 electron, then you are correct-amundi. It needs to gain 1. It needs to fill the one up here. It can't lose 7. So rule number 10 on your rule sheet. Atoms lose or gain electrons, and they do whichever is easiest. So it's much easier to gain 1 than lose 7. That's rule number 10. Have you added it to your chemistry rule book? However many rules we end up with. There's not that many. Next. What does this one do to gain a full shell? And you can have some thinking time now while you're thinking. Counting them up. What's the easiest way here? If you need to pause these before I reveal my answer because you're counting, just pause. It's a video after all. And the answer is it has 3 on the outside. Therefore, does it lose 3 or does it gain 5? And from rule number 10, it will do whatever is easiest. It loses 3. Aluminium will lose 3 electrons. Okay, same again. What does this one need? And hopefully by now you're getting a bit better at this. And the answer is it needs to gain 2. And this is the reason why we sometimes draw dot and cross diagrams. Sometimes you see electrons drawn as dots and sometimes as crosses. If I draw them in here, there's one it's gained, there's the other one it's gained its 2. It now has 8 on the outside. It now has a full shell, following rule number 9. By using dots and crosses, I can show that the crosses were the ones it started with and the dots are the ones it's gained. So, it's blank. Why is it blank? Because in your notes for your teacher to look at and check, choose another one that we haven't done. Choose another one from the first 20. So you might choose calcium, we haven't done that. We haven't done potassium, we haven't done nitrogen, we haven't done fluorine. Choose any one from the first 20 and write down, draw it out, and then write down what it needs to do to get a full shell. So your teacher will be looking for one that hasn't been on the video and is one of your own. Okay. Like you want it to get any more complicated. I think this is straightforward. Sodium on the periodic table has the numbers 23 and 11, which says to me that there are 11 positive protons. And it says to me that an atom has 11 electrons that are negative. And that's why it's neutral, 11 of each. And it says to me that there's 12 neutrons, but we're not going to worry about the neutrons for now. Just the electrons and protons. Here is sodium with 1 on its outside shell. It loses that electron. It even says it, an electron is lost. And now it's here. And just to draw this again, it now has, the nucleus hasn't changed. It has 11 positive protons. It's lost an electron. It started with 11. It gave 1 away. It now has 10 electrons that are negative. Right, it's no longer neutral. It now has a charge. What's the charge? The charge is positive by 1, plus 1 charge on this atom. That will be drawn as it's an Na+. It's no longer an atom. Here is an atom. This is an ion, not an atom. So if I look at this example, from what we were doing earlier in the lesson, here's magnesium. I look at it, I can see, there's 2 on the outside. What's the first thing that goes through my brain? First thing I think is, number 1, I think it needs to lose 2. Okay. The second thing I think of, number 2, is I think it's lost. I think I look at the numbers on the periodic table for magnesium, Mg2412, and I say to myself, well, it had 12 positives and it had 12 negatives. Then it loses 2. So number 3, I've now got it over here, this diagram. Number 3, it has, it's still got 12 protons, positive. It's now only got 10 negatives. So number 4, I think to myself, it is now Mg. And the last time we drew plus 1 for sodium because it lost 1. And now I need to do Mg plus 2. Magnesium with a positive charge. And how big is the positive charge? It's positive by 2. Now, that is how you draw it. So, in your notes now, This is your worked example. Magnesium, here, this is where you start, has to lose 2. You then work out that protons and electrons afterwards. Then you work out the charge, and then you draw it like that. So that can be number 5. So hopefully by pausing and following the numbers, you'll get really clear notes. Okay. Let's start right from the start. Ooh, aluminium has 13 protons that are positive, 13 electrons that are negative. What do I do next? Oh, I go Al, 1 there, 2, that's 2 electrons in the first shell, and then I go 1, 2, 3, 4, 5, 6, 7, 8 in the next shell. Oh, trying to keep it neat. 1, 2, 3, and then I'll say to myself, it needs to lose 3. And then I go, well, hold on, if it's lost 3 electrons, it still has 13 positive protons, but it now only has 10 electrons that are negative because it's lost 3 down there. That means aluminium has a charge of +3. I should really have gone Al 1, 2. Then it's still got its 8 in this shell. 4, 5, 6, 7, 8. It's lost the 3 on the other shell, and then around that a square bracket, and I just show that it's a +3. You might need to go back over the last couple of minutes, that example for magnesium and then the example for aluminium. So this is the end, not the end of all time, but I'd like you to do these ones for yourself. Therefore, here's your numbers, even tells you, there's your original drawing. Then, what's it going to look like afterwards? You're going to draw. What's going to be the charge on it? You're going to do. And you start by thinking, sodium, I remember this one, it needs to lose 1. Redraw it without the 1 over here. So redraw it in there without the 1. And then go to yourself, it started with 11 pluses and 11 negatives. What's it got at the end to work out that charge? So you've got 4 there to do. Those 4 will probably fit onto 1 page in your book. That will take you about 10 minutes, maybe 12 minutes to do. And that's the page, as well as that other one we tried earlier. Send the photos of your work to your teacher. And if you have any difficulties with that, send a question to your teacher so they can go over it again in the next live lesson, or if you need any clarity. Okay, thank you.